Although certain breeds, like the Beagle, German Shepherd, and Bloodhound, can smell better than others, every dog has an incredibly sensitive and complex sense of smell. According to scientists, a dog's nose is between 10,000 and 100,000 times more powerful than a human nose. While we have around 6 million smell receptors, they can have up to 300 million. Due to thousands of years of breeding by humans and natural evolution, dogs have become known as having one of the best sense of smells in the animal kingdom. Obviously, a dog's sense of smell is configured quite differently to our own. The part of the brain that is dedicated to analysing and processing odour is approximately 40 times larger in dogs than in humans. The biological structure of the nose is also an important factor. The long muzzle found in most dog breeds is what allows their sense of smell to be so acute. This is because a muzzle allows for an extensive surface area for odour molecules to pass over and be analysed, and the longer the air containing the molecules stays inside the nose, the more accurate the information learned will be. Something unique to the structure of a dog's nose is a small basal plate of bone which serves as an olfactory shelf where odours can accumulate and still be recognisable even while the air is exhaled. A flap inside the nostrils separates inhaled air into either the respiratory pathway, which is used for normal breathing, or the olfactory path, which is used for odour detection. In fact, their sense of smell is so complex that there is a completely separate section dedicated to processing odours within the context of social contact, including pheromones that are used for the social and sexual assessment of other dogs. It is easy to understand why, throughout history, humans have found ways to utilise the powerful sense of smell that dogs have, and to work alongside them to help us in all types of ways, whether it be agricultural, medical, or assisting those with disabilities. There are many different types of detection dog, including drug detection dogs, explosive detection dogs, arson and carbon detection dogs, search and rescue dogs, bloodhounds, medical detection dogs, and cadaver dogs. Detection dogs and their handlers go through in-depth and intensive training in order to become qualified. This is necessary since these dogs will be asked to work in unfamiliar environments while trying to detect even the faintest of scents. This video will focus on cadaver dogs, and we will see how these four-legged friends have helped to assist law enforcement in solving horrible crimes and helping to put criminals behind bars. Depending on the particular field the detection dog will work in, the training process can differ. It generally takes around 2 to 3 years to transform a prospective puppy into a qualified detection dog. During that time, a great deal of dedication and persistence is needed from both the dog and the handler in order to sharpen the dog's stamina, focus, and obedience. Training a dog to be able to ignore the smell of food, other dogs, and anything that could distract them is crucial, while the handler must be able to communicate and understand the body language of the dog. There are two main types of detection dog. Tracking dogs are trained to follow a trail of human scent by working with their noses to the ground. These dogs need to be given a starting point, often where the missing person was last seen, so that they can follow and track the scent. The other type of detection dog is known as an air scent dog, who instead work with their noses in the air. These dogs don't require a starting point because they are trained to detect a scent that is carried in the air and be able to find the point of origin where the smell is highly concentrated. Handlers will often create a verbal command that tells the dog to start scanning the area for a scent, as well as training the dog to display an indication behaviour when they believe they've found a scent. Since digging or frolicking around could destroy or disturb any potential evidence nearby, it's important for the handler to train the dog to either sit or stand still, wag their tail, or bark when they find a scent. For cadaver dogs, being able to detect the smell of human decomposition is not a natural ability. In order to train these dogs to be able to differentiate between animal remains and human remains, they need regular exposure to human blood and decaying flesh. This is done so that the dog is able to identify the unique compounds that are emitted when a human corpse decomposes, including cadaverine and putrescine. Dogs learn very well through association, so handlers will often train the dog to associate the smell of human remains with their favourite chew toy and reward them with this toy when they successfully alert to a scent. Cadaver dogs are used to locate the remains of missing or murdered people. Depending on their training, this can include entire bodies, both buried or submerged in water, skeletal remains, or just body fragments like blood, tissue, or hair. Studies have revealed that cadaver dogs can even detect remains that are buried up to 15 feet underground or submerged up to 30 meters in water. These dogs work both on a lead being directed by their handler to specific areas of a crime scene, or off lead where they are free to search a large area independently. Cadaver dogs have helped the police solve tragic crimes, helped family members find their missing loved ones, all while baffling scientists and stirring up a huge debate about just how accurate cadaver dogs are. Detection dogs don't always get it right. They have been known to give false positive indications, which means they've indicated to the presence of human remains when there is none in the area. Because scientists don't have a full understanding of how accurate detection dogs are, some people may question the reliability of using them in criminal investigations. The process of teaching the dog a specific alert behaviour helps to reduce the likelihood of these false positives that can happen by both the handler misinterpreting the dog's behaviour or by the dog incorrectly indicating on an area that has not been in contact with human remains. Despite this, courts are often inclined to allow evidence around cadaver dogs to be submitted into trial and presented to a jury, particularly if there was other supporting evidence. Let's look at a case where cadaver dogs were brought in and helped solve a disappearance that had baffled family members and law enforcement for decades. Maria Montano was last seen in Aurora, Illinois in July 1990. She was a 35-year-old who worked as a cleaning supervisor and was married to a man named Aurelio Montano. Their marriage was somewhat turbulent as Aurelio became increasingly jealous and controlling, eventually convincing himself that Maria was being unfaithful. In 1985, he filed for divorce. However, it was never pursued any further and was eventually dismissed. In July 1990, Maria disappeared and has never been seen since. Although Aurelio told his daughter, who was only 10 years old at the time, that she had left with another man, she was not convinced. Years later, in 2006, their daughter went to the police and asked them to reinvestigate her father's involvement in her mother's disappearance. During this investigation, police called in cadaver dogs to search a farm where they had been told that Maria's remains had once been buried. Although Maria's remains have never been located, cadaver dogs separately alerted to the smell of human decomposition on a rug and the hole it had been buried in. In 2008, Aurelio was serving a life sentence for an unrelated double homicide when he was finally charged with Maria's murder. Investigators were not put off by the fact that they did not have a body, as they felt they had sufficient evidence of what had taken place. The murder trial took place in 2013, where relatives and family friends testified that Aurelio had killed Maria by strangling her with some kind of rope, wrapped her body in a rug and disposed of her on a farm, before digging her remains up and moving them elsewhere years later. This was one of the first no-body homicide cases in the state of Illinois, where the trial focused heavily on the expert testimony of the handlers and cadaver dogs. Ellen Pownall of the Midwest Canine Emergency Response Team was the prosecution's star witness. She testified that her 3 German Shepherds had searched the farm at separate times and had each positively indicated to the smell of human decomposition on the rug that was found, which Maria's daughter later confirmed had been in the family home. It is important to note that the prosecution never claimed that the cadaver dog's alert was proof that the human remains that they detected was in fact that of Maria Guadalupe. Aurelio's lawyers argued that the prosecution should not have presented the cadaver dog's positive indications as scientific evidence to the jury without any other form of evidence, such as DNA, to support the notion that human remains had been in contact with the rug or the area it had been buried in. They also argued that it was not explained clearly to the jury exactly how environmental factors occurring over a 17-year period would affect the residual chemicals. Aurelio's defense believed Ellen Pownall failed to explain how the behavior of the dogs changed when alerting to a scent, that she was biased in favor of her dogs, and would not acknowledge the possibility of a false positive indication. The jury deliberated for only 3 hours before they came back with a guilty verdict. Aurelio's lawyers appealed the verdict based on the way the prosecution had produced the cadaver dog's evidence to the jury. However, an appeals court declared that the evidence was in fact valid and that the wealth of other evidence and testimony corroborated the findings of the dogs. Without cadaver dogs, investigators would have to have relied on the testimony of friends and family to explain what happened to Maria, which may not have convinced a jury beyond a reasonable doubt that Aurelio was responsible.